That would be insane to move all these things around by hand. That's not even right. What's going on there? This smooth transition between fiction and fact. Speaking of when things don't work, let's not save that. Hi everyone, my name is Stuart. This is Making Biocinematics. This is a behind the scenes look at making, what's it called? Diffusion doesn't tell molecules where to go. And I want to share a little bit of my process for creating this animation. Not a step-by-step tutorial, but hopefully some interesting tidbits. But I'd love to hear from you what kinds of things you are interested in seeing in these behind the scenes videos. If you watch the video, you probably know that most of the animation is this kind of glass box of spheres bouncing around, kind of a representation of a gas simulation. Towards the beginning, I kind of have this little console pop up, and this is, I'll pop over here. This was just a little throwaway gag that I was setting up these simulations with this little console command line thing, which isn't actually how they're set up, but I thought it was funny for those that, I don't know, maybe it's not funny. But this is actually behind the scenes. So this is Houdini, and this is what I use to do all of the animation in all of the videos that I've released this year. All of these spheres, what we're using here is what's called a rigid body dynamics simulation. Even the simulations here with the molecules are just using spheres to bounce these things around. So that's what we've got here, is we've got a mathematical engine to tell these spheres where to go and how to bounce around. So I don't have to do all of this by hand, obviously. That would be insane to move all these things around by hands. And that's what computer simulations are for, is to take some rules, some set of parameters, and off you go. What's going to happen? And decides, okay, so this ball's going to go over here and bounce off the wall here and go over here and bounce off the wall here. The nice thing about Houdini, if you're interested in the kind of comparisons between 3D applications, I used Maya for about 10 years, and now I'm learning Houdini for some of this biomedical animation, because I think that the way that it handles data is rich and powerful. So the idea that you can have some input data, you set up all these rules that make things happen, and stuff happens, and you can change the rules and tweak the rules, and different stuff happens. That's really powerful and flexible, as opposed to some ways of working where you're creating one thing, and then if you later on you realize, oh, I need to go back and tweak something that happened early on in the process, that's really difficult. Then you got to go back and redo a lot of work. The whole idea with Houdini is that all of your steps, the steps that you took to arrive at a certain point, are maintained and they're made visible for you, so that you can just go back to one of the early steps, make a change. If I wanted to simulate cubes instead of spheres, obviously that wouldn't make sense in a science context, but for the sake of example, I can make them all cubes. In fact, now they're all cubes. Like, you can do that. Cube. Okay, so let's not save that. So another nice aspect of this kind of handling data in a procedural way with Houdini is that you get a lot of this kind of data visualization for free. So the fact that I'm counting the number of particles on the left side and the number of particles on the right side, I hope that's clear from the animation that that's what it was doing. So 200 particles on the left, 200 particles on the right, and I'm using that to demonstrate that a dynamic equilibrium isn't static. It's not always 200 and 200, but it's roughly the same as particles continue to go back and forth. But all I had to do was create a little expression that says, count the particles that are over here and count the particles that are over here, and then put those numbers in a text, object, whatever. So speaking of the simulations, this particular shot was an interesting challenge, because what I wanted to convey was the idea that you've got this false sort of representation of how molecules are moving around. You spritz some perfume and it's traveling more or less across the box, but I wanted to kind of move around in sort of a semi-realistic way, so it's almost plausible that that's what those molecules are doing, but it's clearly that's not what happens in real life, because you know, the stickman is like, I smell it, and then suddenly you don't smell it anymore because it's traveled past. So at this point in the simulation, now I want the perfume molecules to actually diffuse in a proper sense. So what I ended up doing was kind of creating this two-stage simulation where I have a very controlled spread, and these forces are pushing just the purple molecules. So the background air molecules are a completely different, they're a separate simulation, and the purple molecules or spheres are a separate simulation that's more controlled. And then when we get to this point, basically I'm like capturing that state with the velocity of the purple spheres and the velocity of all of the other air spheres, whatever, blend them together, but maintaining all the velocity, so it's not like this sharp, you know, obvious transition between the two states. And now at this point, I don't think you'd ever be able to see it, but in theory, the gray particles can collide with and influence the motion of the purple particles, and they also, you know, just kind of go everywhere. Sort of like trying to create this smooth transition between fiction and fact. Speaking of this shot, the other thing that you might have not considered is these stickmen characters are just 2D drawings, right? Yet I'm trying to put them inside the box so that some particles are moving in front of them, like most of these purple particles, but subconsciously maybe you have this sense that like some particles are going behind them. How was I going to do that? Well, I could have sort of drawn them and put them as like kind of cutouts, sprites or whatever in the 3D scene at a certain depth, and that could have worked, but I ended up wanting to do the drawing after the fact, after all the simulation and rendering was done, so that I could kind of time the expression changes and kind of tweak that after the fact. So here we are in Photoshop. Basically for these shots, what I ended up doing is creating sort of like frame animations here. So there's different layers. Basically the background is just reference for me when I'm drawing, so I know approximately where to put the objects and characters. So I hide the background and export all of these images just as with transparent backgrounds. Oh no. So this is Fusion. This is the compositing application that I've been using. A lot of people use After Effects for this kind of thing, and After Effects is totally fine, and I used After Effects a lot, but I'm interested in doing some of the node-based compositing, and Nuke is too expensive. And Fusion is actually a pretty good tool. It can do some pretty interesting things, and I'd like to learn more about it. So I've been using it for a little while. I'm not an expert by any stretch of the imagination. And so instead of having layers like After Effects has, where you stack up different parts of your image and stick it all together, basically you're putting parts of your image together with these little nodes. And I'll try to show some of this. So you usually never do this because you start looking back at, you start looking back and you're like, what, that's not even right. What's going on there? No, it's okay. So basically what I did was I rendered out a mask out of my 3D scene that was basically a plane that was stuck through the middle of the box. So all of these black dots are the particles that are in front of the plane. And if you kind of mask the characters using this white and black areas to punch out, where it's black, the characters will get punched out, not in a violent way, then you basically let the, this comp is a little bit broken. That's okay. Not my fault, probably. So we've got a mask, we've got our characters, and if we tell the black parts of the image to punch through, and then instead of the purple stuff actually being in front, it's just that these are the places where it's punched through. So this was another scene that really worked well in terms of using the procedural nature of Houdini. what I ended up being able to do was, instead of making this as a 2D graph and kind of hand animating it or kind of estimating it, I could actually take the actual proportions of the red and the blue spheres and do a little calculation and just make that in a graph. So we can see that in the 3D scene, this is an actual three-dimensional graph. I mean, even the lines of it are actual cylinders. And the reason for that was just that that was actually just the simplest way to approach it. Sometimes 3D seems like a really complex way to do things, but in this case, it was just easier than doing anything else. So basically all I'm doing is I've got these sequence of red spheres and blue spheres, and just on every frame or every couple of frames, just put down a new one that's corresponding to the actual proportion, and you know, progress over time. And again, like, where's the other graph? Well, I only had to make this once, and then I just had to change the initial proportions and run it a second time. And if I save out that data onto my hard drive and just load up each of those simulations for each one I want to render, right? I don't need to get into what these are doing. I just wanted to point out that, like, you can just have one scenario and another scenario, and you can kind of queue them up and off you go, which is a really nice and efficient way to work. When it works, it's a ton of fun. I'm over here now. Speaking of when things don't work, so this was interesting, and this is something that I wanted to figure out specifically for this project, and something that I'm going to be able to use in a lot of different projects. And that's the idea of tracking a two-dimensional object on 3D data. What do I mean by that? Well, so this whole scene is in 3D. It's a computer simulation, but this arrow is just a 2D graphic that I added on in Fusion. Tracking 3D data is something that's pretty common, but I had a problem. So here we are in Houdini, and here we have our tracked molecule, and this kind of traces kind of similar to how I did the graphs. It's just kind of tracking the points along over time. So that's a full 3D object, but the arrow is not in this scene. So how did I do that? Well, basically what I did was I got this little box, and you can see this tiny little box, and this is tracked all the way along on every frame, you know, as we go back and forth, and it's grabbing the X, Y, and Z coordinates in 3D space, and then I can pass that information into Fusion. And then in Fusion, I can bring in the camera, I can bring in this locator, and I can sort of see it in this little white cube in my frame. And that should correspond to the position of the particle. And so then I could take an arrow, like so, and just basically stick that on and have it follow along. So far, so good. But when I merged it all together, so this is the little square that I'm supposed to be tracking, it's not on top of the molecule. And I checked, it's right on that frame 103, whatever it is, it's right there exactly on that sphere. But here it's not. Why is it not exactly there? And I looked at all the parameters. I was doing calculations on like the film back of the camera. Is the data not coming in correctly, where like the aperture and the field of view and that information? No, it's supposed to be, and the way that it's interpreted is a bit different, but I actually did the calculation. It's fine. That shouldn't be it. It's not a time shift. It's not that there's like an offset period of time. It's not like that it's always just in front of it, because depending on where it is, sometimes it's in front of it, sometimes it's behind it. It's just not on. I like it when things are exactly on. And then I realized what the problem was. I'll tell you what the problem is. I'm bringing in the 3D coordinates as they are relative to the camera, right? When I'm rendering this image, I'm using a renderer engine that simulates light in a realistic way. And when light passes through glass, the light rays are bent or distorted. And so in this little aquarium of air, as the software is rendering each of these particles, they're there's a little bit of distortion. And so that 3D data that's just coming in raw, there's no light rays being traced for that. It's just raw 3D coordinates. And that's why this is as though it's bent like a spoon in water. And this is just straight up what the coordinates are. And once I figured that out, I was like, well, there's a way that I can fix this. And that would be to calculate the ray through the glass and the angle of incidence and how much it's going to be refracted, and then actually offset the 3D coordinates by that amount. What I actually did was I said, it's close enough. It does bother me deep down. It's close enough. So I hope that was of interest to you. If it was, give it a thumbs up. Maybe subscribe to Making Biocinematics. Subscribe to Biocinematics itself if you haven't already. But here's the thing. Currently, I don't have ad revenue from these animations, and I really want to keep making them. I've been fortunate enough to do so kind of out of pocket for the time being, but that's not sustainable long term. So what I've done is I've started a Patreon page. You probably know what Patreon's all about, but if you don't, basically you're pledging a small amount of money and you'll get perks and rewards in addition to the most important thing, which is supporting me to continue to make biology animations and making them all free forever. As an example, this webcam is pretty low quality. It's very old. It's HD 720p. I can't even fill the screen. I have to crop it and then shrink it, and it's still pretty poor quality. If 10 people sign up for the Patreon at least $3 per video, then I'll be able to buy a new webcam. And you can see me in much higher quality for the next behind the scenes, which would be, I don't know if that would be good for you. It'd be good for me. And you'd get to download videos and get other things like project updates. You get to vote on polls, and if you sign up for $5 a month, you get downloadable graphics. Cool stuff. So give it a look, see if there's anything that piques your interest, and thank you for supporting me. I really appreciate it. I'll see you next time. I'm Stuart, and this is Biocinematics. Yeah, this is incredibly boring and tedious. Wow. Make it interesting. Make it interesting for who? For who? I don't know. Who are you? Who's watching? Is this interesting?